start streaming. Okay, it seems to be on. Yeah, okay. Show my face. Let's make sure the sound is nice. Yeah, okay. Yeah, seems fine. Seems fine. Alright, in this one, I wanted to continue what I did yesterday and explore like just CPU scheduling. Yesterday, I only did a tiny bit of that. So yeah, yesterday I mainly did the mlock thing, memory locking, and so I did a tiny bit of nice, which I solved my example yesterday. But hi again, hey, hello. That was very fast. I'm guessing you got a notification maybe. So in this one I'm just gonna look. It's gonna be a very boring stream, I'm afraid, where I just look at the schedule man page, and I try to understand all of these syscalls and all of the scheduling policies and so on. I did a tiny bit of research yesterday, so to not be like a complete noob and bother everyone, but yeah, there's a lot here. So, how can I check this? First of all, the man2 get priority. Get program scheduling priority. The scheduling priority of a process group, or user. User can have a scheduling priority. That's surprising. Indicate by which or who is obtained with the get priority. Oh, okay. So it's int which id who. Okay. Is obtained with the get priority call and set with the set priority call. The process attribute dealt with by these system calls is the same attribute, also known as the nice value, that is dealt with by nice. Okay, so this is just a generalization of nice. I see. So actually, let's just copy paste the nice examples here, like so. We can remove that, we can remove that, like so. We can remove a lot out as well, even though it's gonna show back up. And so let's just do something like remove the niceness thing, and instead let's just get priority. So int prior is equal get priority, like so. And I'm not sure yet what I should get. The value which is one of the prior process, prior p group, prior user, and who is interpreted relative to which. A process identifier for prior process group for p group, and a user ID for. Aha! I see. So I'm curious. Let's see what my user prior user. What is my user priority? And so I think my user ID is 1000. I need to include sys resource.h, like so. And so the return value, I assume, is on success. Get priority returns the calling thread nice value, which may be a negative number. On error, it returns -1 and sets error. But that's... What if the priority is -1? How do I know there is an error if the priority is -1? Okay, I think we have to do something like set erno to 0. Erno.h, and then if erno is different than 0, p error. Like so, just to check if there was an error. I mean, I would prefer to check the return value, but I think that wouldn't be very wise. And so get priority just returns -1. Oh, they say it here. Since a successful call to get priority can legitimately return a value of money, it is necessary to clear erno and check erno. Yeah, that's what I just did. Set priority returns 0 on success failure. Okay, the other one is simpler. Let's just do something like, yeah, sure, something like this. Oh, yeah, maybe just for the... I will make it shorter just to see what happens. So... Oh. I have to print it, otherwise it doesn't work. Prio is gonna be something like this. Prio -11. Huh. Wait, and I am UID 1000, so that works. What if I have a user ID that doesn't make sense? Okay, that makes sense. No such process. A bit of a weird error message, but that works. So my user priority is -11. That's surprising. What about my process priority? Process, and it's gonna be, well, whoa, I don't know, what, stop it. What the fuck happened? What the fuck happened? I don't know. Like so, let's keep this one as an example. Let's do prior process, and we're gonna do get PID. I think that's a function to get the PID of the current process. Yes. So I can just do this. Let's see. And so the process by default has prio 0. Okay. And then there was a P group as well, which is GPID. GID, get group identity. No, that's not it. PG, this. Set process group, get PGID. PGID, and this is get PID. I've never used process groups before, but I assume it's just, yeah, you can just have a group of process and then, I don't know, do an operation on all of them or something like that. Maybe change their priority to all of them, in our case. So the process group also has a priority of 0 by default. Anyway, okay. And so if I change the niceness of my process by 1, so yeah, let's remove that. So niceness is an increment, so I will increase it by 1, and then we will just copy paste this like so, and now the priority is 1. Okay, that makes a lot of sense. And wait, let's put let's put this back like so. So I can change it with the nice thing, but I also can change it with the set priority thing. Set priority for prior process, then it's gonna be get PID. I don't know why the highlighting is so weird. And let's just set it to 2. Oh, so the priority is also like the niceness, like the highest priority is means there is less priority? That's weird. Wait, let's check. Okay, so I can change it like this as well, and it's the same as nice. Well, except that this actually sets it, and nice increments whatever the previous value was, so I could do something like this, right? Like I do nice of two times, and then my priority should be 2. Yes. Get priority. So scheduling priority of process, user, or something. Yes, that's fine. Value which can be process group, or user that I just did. Process group identifier for prior P group. And a user ID for okay, that makes sense. A 0 value for who denotes respectively the calling process, the process group, the process group of the calling process, or the real user ID. Okay, so I could have done like the exact same by doing 0, 0 and 0. Okay, so this is only like the non-zero version is only if you want to get other processes or other users thing. But how do you get the priority of root then? Because root has user ID 0, right? Yeah. That's very odd. That is quite odd. The prior argument is the value in the range -20 to 19, but see notes below, with -20 being the highest priority and 19 being the lowest priority. Attempts to set a priority outside of this range are silently clamped to the range where default priority is 0. Lower value gives a process a higher scheduling priority. The get priority call returns the highest priority. Lowest numerical value enjoyed by any of the specified processes. What? What do you mean I can specify multiple processes? Call sets the priority of all the specified processes to the specified value. Traditionally, only a privileged process could lower the nice value. Can increase the nice value target. Suitable, limit nice, soft nice. Okay. But anyway, the get priority and set priority don't seem that interesting. It's just a more granular interface over niceness, as far as I can see. Yeah, that's about it. Okay. Well, let's rename sked to sked to just, I don't know, get priority, something like that. Now, let's make another D called, I cannot spell, it's the scheduling. Okay, what's next? Set scheduler. Set the scheduling policy and parameter of a specified thread. Sorry. Let's see. I wonder if you can hear the background noise of, I mean, I don't know, there's a few cars passing by. I hope not. I hope the the noise cancellation can suppress it. So set scheduler. Wow, that's a bit too much. Okay, again, the chat is auto-translating your message. So the original message is in French. This is very confusing. Tu as lu le livre Operating Systems, Tree, Easy Pieces ou pas? Excellente lecture pour ma part. No, but I'm a Zoomer. I don't read books, but maybe I should. Operating Systems a 3 easy pieces. 3 easy pieces. That's a bit strange. Well, not strange, I'm just wondering. Okay, that doesn't help me. Oh, it's free! I'm definitely gonna read it then. uh, okay, this, I think my dark stuff makes it... Oula, sorry for your eyes, but... Now feel free to... Okay, what do they talk about? CPU scheduling. Oh, it's all free. That is nice. Where the three easy parts are virtualization, concurrency, persistence. That's 4 parts, because there is security after. Yeah, that does look nice. Thank you for the recommendation. Table of content. Virtualizing the CPU, virtualizing memory, concurrency, persistence, design goals. Huh. And are the chapter manageable, or is it like 50 billion pages? No, it's actually manageable. That's very nice. I don't know, I think I've been traumatized a couple of times just looking at, oh, this book looks cool, and then I open the first couple of pages, and it's like a preface that is 50 pages. The guy is congratulating the whole field or something, I don't know. But this does look nice. Huh. The thing with books about any kind of general computer science topics is I feel like they sometimes get out of date very quickly. I think, for example, I read some chapters or something about some optimization or something, and at some point I realized, oh, but those don't make sense, because like a real program would use like modern instructions or something, and it would crush that algorithm in another way, you know? So, but yeah, I mean, I guess if it's general concepts, it's probably good. I just wonder, when was the last version? Oh, 2023. Well, that's pretty good. All right, well, it is bookmarked. Bookmarked. All right, let's go back into it. Set scheduler. Man. Et set scheduler. Actually, an easier one would probably be set affinity. Because what affinity is, it's just that you say on which CPUs your program can run on. And that's quite nice if you have a real-time application. You just set each thread to one of your CPU cores, and then you can, I think, it makes it slightly better because, I don't know, the cache is invalidated less often, I would assume. I think another technique is like basically removing some of the cores from the available cores for all applications. So like the kernel won't spawn any programs on those cores, and then you say to your application to use these cores which are unused by anything else, and then you're really guaranteed that the CPU cache and so on is clean. But to do that, I think you have to set something in the grub menu and so on. Maybe I should spin up a VM, like instead of a container, and then I would be able to do these kinds of things. Yeah, that's actually a cool video. Let's rename this to Schedeaffinity. Like so. Okay, so this guy. Let's remove it. So this. Let's have a main.c. is TTIO, like so. So man, set affinity, let's see. So we're gonna have to include scheduling, like so. And so schedule, let's just do get affinity first. Affinity, I don't know why it doesn't autocomplete. Oh, because I have to define GNU source, like so. Let's just define it above. And then the PID, I assume maybe it's the same, where if I put 0, it's gonna be the current PID. Then the CPU set will be, the CPU set size. Okay, so as far as I understand, the CPU set is just literally, yeah, you say on which CPU it can run. So I forgot how to manipulate it, but I think we're gonna have to do CPU set T, CPU set, something like this. Then we're gonna have to manipulate, but I'm guessing we need to say CPU set, the size of it, and then we need to give it as a give its address as an argument, like so. Yeah, I think so. Let's actually read the thing. A thread's CPU affinity mask determines the set of CPUs on which it is eligible to run. Okay, I assume by default it's going to be all of them. On a multiprocessor system, setting the CPU affinity mask can be used to obtain performance benefits, for example by dedicating one CPU to a particular thread, i.e. setting the affinity mask of that thread to specify a single CPU, and setting the affinity of all other threads to exclude that CPU. Okay, I see. Good morning, hey. Bonjour. Gaddy. The voice is not great. It is possible to ensure maximum execution speed for that thread. Restricting a thread to run on a single CPU also avoids the performance cost caused by the cache invalidation that occurs when a thread ceases to execute on one CPU and then recommences execution on a different CPU. Okay, this is a more detailed explanation, a better explanation of what I was saying before. I think also on some machines, you have, like on heavy servers and so on, you can have a machine that has I guess generally 2 CPUs. And so if your process goes from one CPU to the other CPU, it's a big cost. I think here they say CPU, but they mean like, I don't know, CPU core, you know? So yeah, I wonder how that works with hyper-threading. Maybe actually CPU here means virtual core, so you can pick, one hyper-thread, one thread to run on. Huh. By the way, I saw a presentation for high-frequency trading systems, where the guy was explaining like what optimization he made to achieve the lowest latency possible. And apparently he decreased the latency by disabling hyper-threading on his Intel CPU, which is kind of counterintuitive. But I assume if you have like a single process that needs to run really fast, that makes sense. But yeah. Okay, a CPU affinity mask is represented by the CPU set structure. A CPU set pointed to by mask is a set of macros for manipulating CPU sets described in CPU set tree. Okay, CPU sets. Okay, so that's kind of basic set operations. Do I have a... CPU 0, so we can set a CPU, we can clear a CPU, we can say if it's set. That seems a bit overkill for... I don't know, I just want to say Oh yeah, no, well, I guess you may need at some point to just set a couple of them and do like the not version of that to exclude the rest. I don't know, it's not very clear what I'm saying, but hopefully you understand. Yeah, that seems very complicated for something so simple. CPU alloc, CPU free. Am I supposed to allocate it like this? This is a bit strange. Do they have an example? Oh yeah, they do, okay. So, something like this. Oh yeah, I'm supposed to do CPU alloc and CPU. Okay, never mind, I was wrong. Let's do something like this. And can I do this? I'm pretty sure that doesn't work. Yeah, it's gonna be CPU alloc size, like so. Yeah, why are you complaining? I'm not sure. And I need to have this guy as CPU alloc, and the count can be 1, I guess. And we're gonna have to do CPU free, like so, CPU set. That seems correct, right? Yeah. Oof, this is a lot of functions. Clears set so that it contains no CPU. So, okay, sure. CPU 0, CPU set. Yeah. Then we can add a CPU. So CPU set 1 to CPU set. Is that correct? CPU set? Yeah. Not 1, I meant 0. I assume the CPU ID is just a number going from 0 to 32 in my case. How many CPUs do I have? I have 16. Never mind, I'm not that rich. So sure. Why is it complaining? Oh. So I said get affinity. Oh, what the fuck is going on? Do they have an example here as well? Oh, okay, nice. That is gonna make it much easier. So they have a set. Wait, I don't need to allocate the set. Why do they make me allocate the set? I'm very confused. Also, I put 2 semicolons. CPU set, and then they do a fork, whatever, and then the child. The child is child CPU. Yeah, sure. If sched, if schedule a set affinity. Okay, indeed, if you put 0, it's the current PID. CPU set. Okay, they have one set, but they reuse it in both the child and the parent, which is a bit confusing for the example, but okay. That's just for memory duplication of fork. And loops, sure. Parent CPU. Okay, so they don't have an example for get affinity. So let's just do set affinity. And it was what I specified above. So yeah, I don't understand what I did wrong, but okay. Why do they have an alloc if I can just do this? I don't get it, but okay. What are you trying to do? Just playing around with scheduling set affinity to see what it does. Apparently, it's a good way to optimize your application by specifying on which CPU cores it can run. so that you kind of reserve one core of your CPU for your application, or like for each thread of your application you reserve a CPU, and so that means that the cache of this core will be just for that thread, and so there will be less cache invalidations and so on. And also, if you don't have to move it around, you don't have to move the context around, which takes a while. Anyway, you can just do man sked set affinity and read this paragraph, and it will explain better. I have no clue what CPU alloc is for either. Yeah, I don't know, but let's just try it like this. But I mean, it won't do anything, but I just want to see that it compiles and run, let's say. Like so. And now let's just do the... how is it called? Nice main. I'm just gonna go copy and paste the loop, just so that we can have something that runs up. Like so, like so, like so. And let's just do time. And I wanted to... So it runs for a while. Okay, it runs for a while. And I just wanted to see... Okay, this interface is a bit cluttered. Is BTOP any better? It's not. Okay. I just wanted to see that it actually goes on CPU 0. Yes, it does. So this guy is... I don't know if you can see, but yeah, it's gonna be the top one. And so if I change my main.c and I say it should be on CPU 2, then it's going on CPU 2. That's... Oh! Wait, it went on CPU 3. How did it? I'm not sure. Wait, let's make it run longer. Should be on CPU 2. What is it doing? Why is it on CPU 3? Seems like it's moving it around. That's odd. Huh. Or maybe it's pausing the process, or as they call it, preempting it, and just replacing it with another application. But look, it's going on 3. It's very odd. Hello, I've seen your Advanced videos. Thank you. Thank you for watching. Sup, first time here. Well, welcome. I myself pursue electronics. Working on 85 and 8086 was a mess for me. This sounds even more intense. I did a tiny bit of things on the 8086 computer, and yeah, it was... I mean, I don't think I reached the hard part yet. I was just following the Ben Eater videos, but it was very tedious, let's call it, like wiring the whole thing and so on. I'm surprised that only 2 cores are getting spiked. Yeah, but only one should get spiked, because I set the CPU to be only on 2. Oh, is it just a very dumb thing? Wait. Do I have to 0 it before? Maybe it's that dumb. So it should only be on 2. Stay on 2. Stay on 2. Yeah. Now it seems like it's staying on 2. I don't know how it shows on stream this HTOP, but now we can very clearly see that the CPU core 2 is at 100% all the time, and it never moves it around. Oh, I wonder, because I have one of these Intel CPUs that have like P cores and E core, and like the P core are the performance core, which are much better. And so I wonder if I can detect which CPU cores are P and E, and then we try to run it on a P core, see the time, and then we run it on an E core, and we also see the time, and then we can showcase a bit the difference. Okay. So indeed, I had to do CPU 0, which makes sense. Newbie mistake, you know. Let's see. Let's ask the Clanker. Oh, that's the chat. Like so. Like so. How to check which CPU cores are P core and E core on model Intel Linux. Put back the thing. Yes. LSCPU extended. Sure. Let's do that. Let's do that. Wait. So let's make a bit less iterations so that we don't have to wait 40 seconds every time. And then we have a bunch of CPU. The node is always 0 because I only have one of them. Oh, what's the difference between node and sockets? It's a bit weird. Just subscribed to you. Hope to see more amazing content like this. See you later. Bye. Okay. Well, there is plenty of content like this on the YouTube channel, so I hope you enjoy. Okay, this is a bit weird. Can't really tell. I mean, there is the megahertz here, but that's the current ones, right? Yeah, that's just the current one, so it doesn't seem to matter. Oh, wait, no, we can't see them. Isn't like the max megahertz, right? Where those are the E cores, and those are the E core, the P core. Wait, NeoFetch. Let's grab my CPU model if I can. This guy. Up. So I forgot the specs. So let's see how much P core and E core I have. So performance core is, oh, indeed. Okay, I only have 4 efficient core and 6 performance core. Huh. Yeah, well, it's not 12 performance core, it's just that the performance core have hyper-threading, so it's times 2, and the efficient core don't have it, so yeah. Okay, so anyway, no, let's just do this. And so basically the, like, 12 is a efficiency core, so let's first just run it, see how long it takes. Should take around 10 seconds. Oh, 5 seconds, never mind. And yeah, maybe I should make it run for a tiny bit longer. Let's say 2 times longer. Just so that we have a slightly more precise number. Okay, 8 seconds, it was expected, and then we set it to like 14 maybe. That's for sure an efficiency core. And let's make sure it ends up on that one. Oh, and we can see also the megahertz on HTOP, and so we see that this one is capped at 3400, and this one was capped at 4900 or something. So it should be, I guess, a quarter longer, since there is a quarter less, how do you say, frequency. Well, I guess with the hyper-threading, it will slow down the P-core a tiny bit as well, but... Damn! That's a huge difference. What the... Am I sure I did the... Oh yeah, the sum is the same. God damn. E-cores suck. Yeah, that's That's crazy. I wasn't expecting that at all. I was expecting like, I don't know, 12, 15 seconds, like a tiny bit slower. This is huge. Let me put that in up notes. Let me just save that for the video maybe. Well, this is actually nice. This is a nice showcase, I guess. What else can we do that would be fun? So, I mean, I would have to simulate kind of I really want to do some. Maybe I should like spin up like a lot of tasks on my CPU, but then will that crash the stream? Do I have to create a VM? It's not very fun. What is the agenda for the stream, by the way? It's just what we're doing right now. It's just exploring the scheduling thing on Linux. So if you type man sched in your on your machine, if you have a Linux machine, I'm just going over all of these functions and see what they do. Basically, I already went over nice and get set priority, and now I'm going over the get and set affinity function, where it says on which CPUs your program can run. Cool t-shirt, I know, right? I know, right? Do you even lift? Those you even I don't know how to speak old English, but yeah. Do you even lift? Well, that's a good question for the chat. Do you even lift in the chat? If you're not, you should. Or at least you should do sports. It's pretty good. I don't want to create a VM. That sounds super mega boring. Alright, it's VirtualBox time. It's gonna... Yeah, let me move some windows around because this is a bit of a nightmare. So this guy, sorry for your eyes, by the way. I must look super white on stream. Spin it up fast with Vagrant. I've never used Vagrant in my life, but I feel like I'm gonna get distracted if I spin it up with Vagrant. I should get one of the do you even compile, bro? Yeah, that's... Then you have a guy in armor just like sweating in front of a computer. That's pretty good. I mean, okay, I'm gonna explore Vagrant for like 2 seconds because I'm lazy. Where did I put this? Vagrant. Let's see. Can I ask the clanker to do it for me? Setup auto mode always. Set up a VM with 4 cores and a, I don't know, 8 GB of RAM with Vagrant. Let's try it, but I mean, if it takes more than like a couple of minutes, let's give up on it. Yeah, running auto mode. Oh, I have to install Vagrant and so on. Okay. But the thing with Vagrant is, can I just go in the VM and play around, or is it... Okay, I have to install it. Yeah, this seems a bit more complicated. Like, even with the clanker, like, this seems a bit tedious. But I should learn Vagrant, it's pretty nice. It's just that throughout all my career, I've never used like let's say a VM supervisor kind of thing. I've always have been using Docker, Podman, or Kubernetes. I mean, yeah, I've asked some dude at some point to create a VM for me, but that's where as far as it goes. Yeah, it provisioned VirtualBox for you so the clanker can do it fast. Yeah. But then can I have an interface where how much do I really want to spend on this? I don't want to spend too much time on this. I'm just gonna create a garbage VM. Sorry, but I'll explore it later. I think it's cool and it's kind of missing in my toolbox. New, and then we put that full screen, and then let's get test. Sure, whatever. I have to. Debian, Arch Linux. I don't really want to spin up a thing, so just Debian is fine. Yeah, sure. Oh, can I? Wait. No, not that. Do I have Ubuntu? Yes, I do. Ubuntu, even easier. Let's go. Yeah. Why can't I? Oh, I already forgot how to. VBox user. Do you want to hack my VirtualBox? Should I just say admin? Please don't hack my VirtualBox. Let's get test. Domain name, sure. Install in background, sure. Base memory, 2 gigs, fine. CPU, that is the part where I need like 4. 4, sure. Can I pick which CPUs though? Well, I guess not. Sure, doesn't matter. Okay. And then there we go. We have our. But the installation of Ubuntu is gonna take forever. This is not gonna be super fun. And can I do this in Docker? No, because I need to. What I need to do is I've read that you can disable some CPUs for all of the application, but in you have to go in grub and so on. Docker doesn't have a grub. Oh wait, there is just yeah, welcome to Ubuntu. Maybe I shouldn't have picked Ubuntu. What do I do? What do I do? I mean, okay, this is already taking too long. Okay, well, I can do like the backup installation of Ubuntu, and in parallel, I will ask the clanker to set up Vagrant with the parameters that I want. How about that? So let's just put that on another workspace. Let's go back in there. Let's go back and ask the clanker for help. And let's change models to Sonnet. And let's read. Let's do vagrant file. Set what is in the vagrant file, because I don't know it, but I mean, can't be this guy. So it picked Ubuntu, yeah, hostname, 4 CPUs, 8 gigs of RAM, yeah, change to 4 GB of RAM. Wait, the other one is 2 GB, so let's do 2 GB of RAM. It's using VirtualBox, that's fine. And set up the grub, I don't know, and set it up so that only one CPU is available for regular applications. And I'm gonna have to install Vagrant. So let's go there. Let's do yay s Vagrant, like so. I'm assuming maybe Arch Linux instead of Ubuntu. Yeah, but does Vagrant does the whole install for me? I mean, distribution, I don't know. Okay, I'm gonna have to type my password, so wait, let me cut my mic. Hello, okay. I guess you need. I do have plenty of ISO Arch, but the ISO for Arch, but yeah. Anyway, let's let it install. Cannot speak English anymore. Anyway, it changed the thing and config VM provision shell inline shell grep grub cmd linux defaults. Okay, it was indeed isol CPUs. So that will mean that only I guess that only CPU 4 will be available for the regular applications, and our application will be able to use the other 3. Do I want this? Well, let's reserve only one CPU for isolation. I guess you need ISO for Arch. Yeah. Sorry, I'm reading the chat twice. I'm getting a bit confused with all of this. Okay. So CPU 3 is isolated. Let's make it simple for us and just do CPU 0. Okay. Okay. Do I have Vagrant? I do. Spin up the VM and me how to log into it. Hello. Hello. We're currently. What are we doing? We're whipping the clanker into submission. That's what we're doing. No, we're trying to spin up a VM where one of the CPUs is reserved, where like no applications can use it except our application. Yeah. Oh, this VM is terrible. Okay, maybe Vagrant plus Clanker is a good combination after all. Oh, how am I? It's still doing stuff. Okay, well. Sure, let's go back to our Vagrant plus Clanker version. Come on, buddy. I have a special trick to make the clanker faster. It's you just say faster with an exclamation mark and then it goes faster. And that's I'm a professional engineer, by the way. God damn, this is so boring. Well, I guess, yeah, I guess Vagrant is nice, but it's still gonna need to do the whole installation thing. So, yeah, I guess that's why you recommended Arch Linux instead of Ubuntu. Can I go this and then How long will this take? Uh, you can do Vagrant SSH after. Vagrant does look nice. This is pretty epic. I wrote a simple kernel with task run to completion. I finished the task and switched to idle task. But the bug I came across was idle task was switching to idle task. Yeah, that's that's not ideal. Um, well, I guess that's, I mean, that's not a bug if all your tasks are idle. But yeah. Hi, did you just start? No, I did some stuff before. Well, the only stuff we did before was using set affinity, which says on which CPU core your program can run. And we compared running this very tiny program on a P core and an E core. So if you know Intel CPUs, like the E cores are the efficient core meant for background tasks, and they're slower. And indeed, they were like, I think 5 times slower than the P core, which was quite surprising. But now it puts in perspective the Intel marketing, you know? The more E cores is on your CPU, the more it sucks. So there you go. Now we know at least. Oh, nice. Um, uh, Damn. Vagrant is awesome. Get away from me, VirtualBox. Get away from me. No, I don't want to save the VM state. Go away. I don't care anymore. Uh, that's epic. Thank you for suggesting Vagrant. Well, I mean, if it wasn't for the clanker, it would have been very tedious, I imagine. But yeah. But the clanker didn't do his job properly because I do not see the ISOL CPU. Oops, fuck. See it, log in yourself and investigate. Auto mode, always, of course. You're welcome. Yes, thank you. Yeah, I didn't have a scheduler, it was just context switching. Oh, I see, I see. I see. Yeah, I really need to get back into the into making a kernel. That sounds super fun to do. Not sure how useful it is, but it's, well, I mean, useful for like your career if you're like a application guy. But it does sound like plenty of fun. And it would be nice to get rid of this black box that has always been here, like when you develop applications on an OS. Yes, you do stuff, epic. I really need to learn Vagrant. This is, like, for testing stuff, it's really nice. Like, yeah. What else could I test with this? Just all kinds of performance related things. Although our performance really, like, how do you say? Like correct on a VM? I guess not always, but yeah. There is some stuff that you can't test in Docker, unfortunately. Uh, um, Well, the clanker does a lot of work, but it also makes the stream very boring, unfortunately. So if you have any questions, now is the time. Um, Yeah, update grub, reboot, something. I just want to do my little test, my dude. Yeah, you can provision your env in a controlled way for testing those kinds of stuff. That is very nice. What was a Proxmox then? Is Proxmox just like the Kubernetes of VMs? Is that a good analogy? Or is Kubernetes the Proxmox of containers? Simplify your data center. Wait. Okay, the website is just garbage. I mean, as far as I understand, it is, but data center, yeah, it doesn't look. I don't know. I don't know, Proxmox, let's explore. Yeah, I don't know. Seems they have like multiple of those programs for like orchestrating VMs, and Proxmox seems to be the one that people are fond of, like at least on the HomeLab people, for the HomeLab people. But yeah, no, I wanted to click on features. Proxmox is a powerful open source server virtualization platform. Kernel-based virtual machines for virtual machine. LXC for containers. Oh, it can do both VMs and containers. What is LXC container? Linux containers. How is that different than Docker? Okay, let's not dive into a full rabbit hole yet. So I set CPU 0 in isolation, and what I need to do is argc argv, and then I will say just int CPU is equal to atoy argv. Cannot type argv1 like so. And I forgot how to say the type of argv apparently. And then we can just have a CPU here and like so. And man, atoy, what is atoy? Atoy is in stdlib, so lib like so. Okay, and now we can specify the CPU on the command line, and what I would like to do is I would like to spin up like at the same time. Oh, I see, it's the arch that Docker uses too. The arch that Docker uses too. Yeah, I wanted a playground for CPU execution, but when I understood execution, I moved on to better things. Huh. LXC, I mean. Oh, yeah, okay. Oh, Docker uses LXC. Huh. Strange. I was looking at like how Docker and like Podman works under the hood just for videos, and I stumbled upon the unshare syscall and so on. And I thought it would make for cool videos to just explain how you can reproduce the Docker setup with a bunch of C code and so on. There is also pivot root where you can change the root of your program, of your process. But then I don't understand why I would need LXC if I already have just a bunch of syscalls. Maybe it's just easier to manage. Not sure. Not sure. Oh, come on, buddy. How long can it take? I tried to use your example in WSL, but it failed to compile eventually after hunting for the header, bits types, locality, and the macro. Use GNU, it worked. Huh. Yeah, WSL is, well, it should be just an Ubuntu VM, so I don't know. I'm not sure what you did there, but yeah, every time you use a function, you have to, unfortunately, you have to do man, for example, atoy, if I want to use the atoy function, and you have to check, like, first of all, the include, but then here there is the feature test requirement. And so that means that you should have like one of those defined, or like sometimes it's by default, you know. What was a good example? Yeah, the get affinity, for example, was like here, so they say you need this include, but you also need to define this before the include. And so you need to just check each one of your functions and like make sure you're not missing any defines. So usually that's why. But in your case, yeah, in your case, it's probably something like that. Come on, Clanker. Well, Buddy is slow today. Vagrant SH. That doesn't work anymore. Okay, well, the Clanker is a bit sleepy today, I guess. I mean, the only thing it does is set up a VM, and then it just reboots it after setting some grub thing, where we isolate one of the CPUs. STR12 versus Atoy. What do you mean? You should make a full sentence. Huh? I'm not Google or the Clanker. But yeah, STR12 is just an extended version of Atoy. Where, well, instead of ints, it returns a long. And you can have an optional NPTR, where it would parse the number and then put the address of the character right after the number inside of the end PTR. And also you can parse in multiple different number base, so you can parse binary, octal, or hexadecimal numbers, and also decimal. So yeah, that's about it. But next time you should really put like what is STR12 versus Atoy, or some kind of words, you know. So he's not swooshing very fast. Can I still not never mind, now I blame the guy that recommended Vagrant. It's all your fault. Definitely not mine or the Clankers. But can I see the status, I wonder, since it's using VirtualBox as a backend? Oh, nice. I can see the status and it just pinned up here, so can I just go in there? I can, I guess. Can I... So I cannot SSH, but can I... Oh, I wanted to see the user and password. Let's just do a... What is the user password of the VM? Just stop doing that. Let me just log in inside. Oh, Vagrant. Okay, let's see. Yeah, no, I'm joking. I still like Vagrant. Oh, oof. Can I not type? Oh, I can type. Epic. I don't know why the... Yeah, it's struggling right now, but anyway. Can I be sudo? Great. Aha, but it did not work at all. That's not good. That's not good at all. Can I quit this? Hello. Oh no. Am I stuck forever? Guy spins up a VM and crashes his stream and stays stuck in VM forever. This is so annoying. So it says write control, but I never understood how you... Oh, finally, okay. God, thank fuck. I thought I thought I got stuck in the VM. Okay, so it's literally the right control key. So like this guy, you know. uh, yeah, I mean it's not htop or vim. It's like when you go in on VirtualBox on the interface. I forgot which key to press to get out of it. Anyway, can I? Yeah, well, htop is also stuck. Can I? Oh no, it's not stuck. It's just that the screen is too large. So anyway, can I redo this? Where? Okay, good. What was the thing again to stress test? It was stress, yes. Do I have stress? Yeah. Let me keep an htop instance on the side of my machine. What? What the fuck is it doing? Oh no. Disk space. Why can't it... Is there not available space? No, it's only 9%. Why can't you install an application? Oh, maybe I need a up-to-date. No, I don't. Is the stream still on? Do I still have internet? What the fuck is this? Stephanie, too bad. It made zero difference on my PC on any of my cores. Well, you should look at what CPUs you have exit anyway. Like just run NeoFetch or something and on your Ubuntu or I don't know, FastFetch. I forgot. Or FastFetch, and it should tell you your CPU model, like here, and then you just copy paste that, put it into Google, and if you don't have P or E cores, of course, it won't make any difference whatsoever. It's just that in my case, I have this very specific CPU. I mean, it's still cool to see that it stays on one CPU, because if you run it without the set affinity, it will probably jump from one CPU to the other from time to time, just because it gets warm, and then it puts it on another one, then it gets warm and puts it on another one. So it was not able to update stuff. This is very annoying. Sage is still not working. Can I just do system mroot, system ctl restart shd, something like this, and then status. It is running. Okay. Can you? You cannot. That is unfortunate. Uh. Okay, so I mean SSH seems to be a thing. I don't know. Let's escape the VM if I can, please. Yeah. Where do I see the network resource? No. 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 Network. I would like to. The fuck. Ugh. Yeah, it's just NAT. So. Oh, this is unreadable. Is that it? Is that it? I don't think so. Yeah, I'm a bit stuck. I am a bit stuck. And Vagrant seems to be stuck as well. Status. Default running VirtualBox. Vagrant halt. Sure, let's kill this. Just doesn't matter. Aha. Well, I halted it like a dumbass, so I'm just gonna restart it if you don't mind. Can I init? No, it's not init. How do you restart it? Not destroy, stop a machine, reload, resume, I assume. Uh-huh. Vagrant cannot forward specific ports on this VM since they would collide with some other application that is already listening on these ports. Uh-huh. Can I start it? No matter what? Maybe I didn't understand fully. And also, yeah, I wonder if the CPU isolation stuff, how does it work? Does it just mean that by default not any task will be placed on those CPUs, but I can still see the CPU? I hope that's it. It's oh, waiting for network to be configured. Oh, I should probably put that on the stream. I will get some water. Oh, it needs a dash in between. Okay. That makes sense. Oh, do I have something running on port? Yeah, I do, but that seems fine. Ah. Oh, okay. Oh, yeah, it's not. It's that's not correct. It's vagrant. I forgot. Okay. Wait, let's go here. System CTL. Well, this stream is turning into how to spin up a VM on your machine kind of stream. Status SSHD. It is active, but it's active on port 22. Do I need to like port forward anything? Or did it already do that? I mean, I was able to SSH into it before. So, needs a dash in between. Resume. The clanker messed up. Yeah, I think so too. But wait, can I just do it the vagrant? This. Can't I just do that? Apparently not. Apparently not. Okay, this is rage programming now. Well, it's more than SSH because if I go here and I do apt install something, like it cannot query the mirrors anymore. Oh, no. This guy. Can I... Is curl install? Okay, can I... Curl... Aha, so... Okay. Yeah, that makes more sense. So there is just no internet on that thing. Okay, no. The VM just doesn't have a network working anymore. Yes, it's rage programming. It's just when you what? Reboot the networking. You do it. What do you mean? What do you mean I have to type stuff? Are you crazy? Are you crazy? Yeah, attempting a graceful shutdown of the VM. Okay, powered it off. I just want to test my little example. Okay, I really need to learn a bit of Vagrant. I think it will be very useful for my, I don't know, all of my performance kind of things. Because, oh yeah, I just thought of something because I was comparing the syscall copy file range, which is just a nice way to copy files around on some file system, but like on, for example, on ext4, this thing doesn't make a difference. You can just do read-write and it will be the same performance. But on something like BTRFS or ZFS, which have, I think, copy on write, or is it XFS? I forgot. They have copy on write. This will just be much faster than read-write. Well, not just much faster, it will be instant. Interface is down, just try to do IP link set interface up. Oh, thank you. I will try as soon as the VM is running. Oh, it is running. Okay, let's just show. Okay, it's still doing stuff. But anyway, I just thought of that because now instead I can just spin up VMs with Vagrant, and each VM would have a different file system, and then I could showcase this syscall. And there is also a very cool optimization where it's if you have a how do you say, a network file system, so you have your file system which is on a remote box and you mount it to your local computer. I think there is an optimization with this where if you copy a file on that remote file system, like if you would do read and write, it would actually transfer the bytes over the network on your machine, then write it over the network on the remote machine. But with this syscall, it would do the copy on the remote machine directly. So that's kind of cool. Anyway, that's a problem for future Charles, but I would like to have my VMs ready, please, sir. Oh, stuff is happening. Great. No, that's not me. Okay. So what did you say? I assume it's the second one which needs to be up, and you said IP. Oh, I don't know these commands by heart. IP link set interface up. IP link. Whoops. No. IP link set enp0s3 up. Operation not permitted. Down. Now it's up. Yeah, it's still not working. Can I just I mean, there is the whole NAT thing, but the thing is that I don't really care. I just want to do stuff fast. I don't need to have a proper VM setup. Can I just go into network, and then can I just replace the NAT by bridged adapter, if I remember correctly? Something like this. Oh yeah, but will I be... I forgot. But then will I be able to communicate with my VM from my own computer? Ah. God, I forgot. Internal network. Not network. Ah, port forwarding. Oh, there's a port forwarding. Hmm. Running now. I put the network interface up, but still no network. Stop what you're doing. Stop what you are doing. Internal network, host only adapter, generic driver, not networked, not attached. I think it was bridge adapter, but I don't want to I wonder if it takes over this interface and then I cannot stream anymore, you know? Also I would have to... Yeah, but you dumbass. You cannot SSH, there is no network. You dum-dum. There is no network on it. You can't SSH. Bridge to communicate. It shouldn't take over the stream. Happy Road Show, okay. Oh no, I have to type the command myself now. Oh no, I'm a disabled programmer because of AI now. Oof. Well, no, nothing. Oh, it's the DHCP client, not a DNS client. Ooh, what the fuck did I do? Oh yeah. DHCP client. And I have to specify the interface. No, stop it. This might be the most frustrating experience of my life. Well, not really, no. File exists. Great. Do we even... Oh! Final fuckingly. Okay, goddamn. Goddamn. No, okay, I understand. You can ping. It's great. Install stress. I don't know why the thing is all flickery and so on. It's giving me like Vagrant, not Valgrind. This. Ah, finally, finally. Yeah, okay. The DHCP thing worked. Great. You can go away now, Clanker. Good job. Good job. Okay, can I do htop? Great. Wait, okay. Now can I Vagrant SSH? Still very slow. I'm not sure why. And it did put something on CPU 0 already, so I know that the thing didn't work, which is very annoying. Oh, it did work! Okay, I mean, maybe someone new to the stream doesn't understand why I'm excited, but this stress command thing, it should spin up like 4 stress tests that we see here. And we see that it's only using CPU core 1, 2, and 3, and not 0, which means that I have one CPU which is available for my application. Maybe. Okay, let's try it. And I can say like 10 stress tests, and it will still not use the 0 one. Epic. Fucking epic, mate. Oi, mate. You want a bottle of water? Yes, I do. God damn. This was not the most fun adventure. But anyway, it works. Let's finally get the example on the way. Do you have GCC on there? No, you do not. And it's nice because I can just do sudo 50 times and not be afraid that my password will leak. Oh, do I need to update? Come on, come on. Come on. Okay, seems fine now. So anyway, oh, what the fuck? Oof, I don't know. What the fuck happened? I installed the compiler. Why do you want me to restart SSH? I don't know, can I just say, don't do that? What the fuck is Ubuntu? Have you smoked crack, Ubuntu? What is this? Do I have GCC now? Oh, nice. How do I run my program, then use htop? When I run my program out, I have to wait for it to finish before I... You can use a terminal multiplexer. Just do... Well, either, I mean, if I think you said you're on WSL, so you can just open a new terminal and type WSL, then enter, and you can have just multiple terminals with WSL, but it's the same VM in your case, so you can do that. That's probably the simplest. Otherwise, you can install Tmux and run Tmux, or you install screen and type screen, but then you will have to learn a bit of key bindings and so on. So I would recommend the first option if you need something quick. What did I wanted to do? Okay, FGCC, great. Now let's just get my main. Let's copy and paste all of this. Like so. Do I have Vim? Yes, I do. Epic. So Vim main.c. Okay, that's cool. I can quit this. I can re-SSH into the VM. And I can do gc main.c. Main.c, not, oh yeah, I have to save it. Okay, and now if I run it, well, let's see, htop. Okay, segmentation fault, I think I know why. It's because I picked CPU. Well, no, I just didn't pick this, so I have to say on CPU 1. Okay, it runs on CPU 1. That's great. What if I pick CPU 0? Oh! Oh, that's so awesome. So, like, none of the processes of my machine can access CPU 0, but my application can. So that means I have a whole CPU core that is reserved only for me. That's what the British would say, fucking epic, mate. It is nice. It is very nice. Okay, how to, I don't know, benchmark this a tiny bit. Whoops, I don't know why I have this open. Maybe this? Yes. Let's ask the clanker how. Well, actually, I already know how to do this. I think. Can't I do something like sec 1 2 3 like so? And then I need to repeat that 2 times. So can you do, I don't know, T, I don't know how to duplicate sequence, format separators equal. I wanted to do something like this, then xargs, a.out, something like that, and then put like the parallel flag to 3. Would that work? No, okay, I don't like it. Parallel. There's the P option. P max proc. Thanks for the help. I just opened second WSL terminal as you said. Nice. And those, sorry, I missed a bit of the chat. That's insane. And also some terminals have the possibility to multiplex. Yeah, that's true. Yeah, that's true. I just have a minimalistic terminal, although my terminal also has this thing. I just don't use it. Yeah, that's true. Just you can, I think it was what? Terminator. I don't know. There is 50 billion terminals. I'm sure you can find something. And those 4 cores are reserved for your VM. Yeah, I think, well, I don't know. Let's just forget there is a host for a second, you know. I'm just excited that let's pretend that the VM is a proper computer. But you see, I saw like a tiny red bar in htop right now on CPU 0. So yeah, again. So but the bar was red. So, and red bars mean that it's a kernel thing. So I'm guessing this CPU isolation is only for like the user tasks, and the kernel can still use that core, which is slightly disappointing, but it's not the end of the world. I'm guessing maybe there is another like parameter to actually like not allow any kernel tasks on there as well. Anyway, let's make it simple. How to spin my a.out multiple times with different arguments. When you switch to Tmux, you don't really care about terminal abilities anymore. Yeah, that's also why I use Tmux, just because you can just use it anywhere. You can use it when you SSH, you can use it, I don't know, once you get, you only have to learn it once, you know. I've been using Zilligili for a while. Easiest multiplexer because the key bindings are visible. What is Zilligili? Not the best name, but let's see. Terminal multiplexer. Is this one of those Rust rewrite kind of thing? I knew it was in Rust, you see? I knew it just from the name. And I knew there was a contributor which had a crab picture. Let's see. Is it any good? Seems fine. I mean, it's a bit over the top to have those. Like all... Yeah, I guess it looks a bit cooler, but yeah. I'm just used to Tmux. So, since the point was to only learn it once, you know. But yeah, that seems nice. I'll try it at some point, maybe. Thank you for the recommendation. The contributors with the little crab picture always get me, or like you see their status, which is also a little crab, and I'm like, come on, man. Don't make your whole identity about a programming language. Well, I say that, but I only do C, so who knows. Yeah, guess I'm gonna do a for loop. But I would have liked to... they need to be in parallel. Oh, parallel task set. Okay, I've never used the parallel command, but does that work? So just not 0, I assume that's the different arguments. What if I do this? Oh, come on, go fast, computer. Ah, why does it... I don't want to restart anything, my dude, come on. That did not work at all. What is task set? Set or retrieve a process CPU affinity. Oh, so what I did in C, you can also just do it with the task set. Terrible name, but okay. Okay, but then that's not what I need. I need to do this, I assume. What a weird separator. Okay. So can I kill it? And then it kills everything. Great. Can I do it twice so that I have multiple tasks? That's not awesome. Okay, well, it spins up only 4 at a time. That's not great. GNU has a command called parallel. Crazy. Yeah, it does. I don't know, I briefly looked at it like a very long time ago, but I never got the use for it because Xargs also has a -p option, which allows you to run all the commands in parallel. So usually my use case were pretty simple, and so I just used that. Well, actually, maybe I can just use it now. What about like 1, 2, 3, 1, 2, 3 Xargs? Okay, and then I replace echo with a.out, like so. And then I have one process, but then I can do P, and the P can be 6 at a time. Okay, well, there you go. You don't need the parallel command, you just need to know Xargs. Well, I guess the parallel is more powerful, but anyway. I'll just stick to what I know for now. So anyway, now I have, I'm trying to just simulate that there is a bunch of processes running on the machine, But can I time it? And so each one of those takes 50% of each core. That makes sense. Let's just let it run and see. I don't really want to get into Rust. Rather than learn Rust, I would want to master C++. Yeah, from what I remember, yesterday you told me that you just started computer science. So I think actually it's not a bad idea to just stick to C, you know, and instead of learning programming languages, you should learn computer science, if you know what I mean. You should just do like projects. I mean, like just pick one language, like C, Python. Doesn't really matter too much, but well, I guess okay, C and Python is a big difference. But if you're more interested about the lower level stuff, I would stick to C. Just explore all kinds of stuff. Okay, I mean it worked, but it's also terrible. The output. Where can I see the real time? Ugh. God, that's horrendous. Input outputs. So 8-second user, but that's not really. I think I want the elapsed time, which is like basically 16 seconds. Okay. But anyway, let's just do this, and in another terminal, I will want to do Vagrant SSH, like so, and I will have my single thing, which will be on CPU 0. So let's start them kind of at the same time. And we should see that this guy basically goes 2 times faster. Oh, 8 seconds. And there you go. Okay, well, there you go. It's proven, I guess. So yeah, reserving a CPU does work. That's freaking epic. And of course, I mean, I could do stress something like this, and then it would like just get all the resource, but not on that CPU, and I could still run my task. So if it's a latency critical application, I would still have the whole CPU reserved for me. So yeah, that's kind of nice. Learning data structures and algorithm in C, big brain. Yeah, that's a nice way to start, I think. I mean, you can just do all kinds of stuff. Because, I mean, for some people, data structure and algorithm is not that fun. For me, it was, but I mean, some people don't like it, so you can just do some. I don't know, the visual stuff was very nice, like drawing the Mandelbrot set or doing some very basic 2D games or just, I don't know, do a tic-tac-toe solver or something to learn the basics of like going through a trees of possibilities or something like that. There's 50 billion stuff you can do. First year of uni, been programming C, C++ for around 3 years. Oh yeah, then go for it. Learn C++. Although, I mean, modern C++ is, I don't know. It's hard to learn computer science and C++ at the same time, I feel like. Since you do C and low-level stuff, would you be interested in making a deep dive videos on CUDA? I would love to, except I don't know much about CUDA. Like I've done some exercise, like LagReduce, or at some point I tried to do like the Barnes Hut algorithm on it, but it was too complicated. I really need to dive back on it. But one of the big pain points was NVIDIA's documentation. It seemed kind of trash. And also their ecosystem was a bit locked. So they had like their profiler, their debuggers, and so on. And it was, at the time, I don't know if it's still the case, but it was quite hard to use on Linux. So yeah. But I would love to dive more into GPU computing. That seems epic. But for now, you have to stick to one topic, I feel like, or one general topic. And my current topic is like CPU performance and syscalls, or like interface with the kernel kind of thing. So I'm gonna stick with that for a little while, I think, just to squeeze out all the knowledge juice. For C++, I hope compiler programmers fully implement modules one day. It looks really powerful. Yeah, it's true that the whole preprocessor stuff causes a lot of headaches. Well, I mean, I think CLang already has it implemented. So let me save that command. I think it was that guy. Up for the maybe future video. So where do I have? I have my notes. So this is for CPU reservation, and I'm just gonna save that. Whoop. Save that command here, and this was P core versus E core, like so. And I think there I can put 14, and here I can put like 0. And then it would be just v grand sh, like so. Okay. Yeah, I think this is some pretty good progress already. I think it has been like 2 hours, and now I have a proper VM setup, which is kind of nice. I think maybe I will take a break and go eat or something. Yeah, it's already 1 p.m. I think I'll go eat. Then I will go do the lifting, and maybe I'll come back. But maybe before doing that, let's quit everything. It was really cool, the performance thing. I think that I might actually be able to use that at work to just reduce latency. I wonder how this technique compares to CPU shares, because you can also assign the CPU shares to your process, and if a process has less CPU shares than another, the other can take 100% of the CPU, I think. Not sure. Or is it, or do shares actually mean shares? Like this guy would take a quarter and this one would take 3/4? Not sure. Does your work care about performance? Yeah. I mean, it's not crazy. It's we do forex trading, so it's like it's not like as crazy as the stock market, where you really have to have like crazy. You really have like crazy latency constraints, but here it's like you do have to work with like sub-millisecond latency, so it's not. And there is a large volume of data, so you get a lot of quotes from different LPs, and you have to be able to like process a lot of information rapidly. I'm dying in web dev. Well, yeah, I can imagine. I'm yeah. Well, I mean, I used to, I don't know, do a tiny bit of web dev, but I quickly realized that it was not fun. Especially the JavaScript. I don't know. It's like the ecosystem is like just crazy. Like 50 people on cocaine creating hundreds of frameworks per day. It's like nothing is stable, and you're just learning framework after framework and not really how to make a website. At least that's how it felt when I was trying to learn it. But yeah. Oh yeah, I wanted to do before I got distracted and before I go away. I wanted to see what I could look into next. So I think what I could look into next was scheduling policies. So affinity we already did. but policies is gonna be the next one. So let's see, man. Scheduling. So which one was there? I think they explain here. The scheduler is a kernel component that decides which runnable thread will be executed on the CPU next. So there is a bunch of scheduling policies. As far as I know, those are like... This is the normal one, the default one. This is for tasks that can only run when there is nothing else running. This I don't know. This is like real time, so that means that it will take over this one, and yeah, like it cannot be preempted. Like your task cannot be stopped unless it's stopped itself. This one is similar to that one, except that there is a maximum time that it can use. Huh. Not sure. Like, what would be a good example for this? What would be a good example for this? I mean, I could just like set up another VM without the CPU exclusion thing, and just have one of my process with which uses FIFO and other ones which uses other, and see that the FIFO one just completes faster. But I mean, that wouldn't be a great showcase since I mean it's kind of the same as just changing the niceness value of the process, you know? This wouldn't really show why you would want to change the scheduling policy. Or maybe I can make all of my process use FIFO, but then I change the scheduling priority between them. But then it's kind of the same. Yeah, I'm not entirely sure. I think I have to research that a bit more to be able to like make an interesting stream or an interesting video. For real, I thought you would be looking at CPU schedulers more like Bohr events and CFS. So yeah, I don't know anything about that, but I think CFS is the one that Linux uses. But you mean like CPU scheduling algorithm, you mean? What is this? I just wanted Wikipedia. There's no CFS. CFS scheduler. Yeah. I mean, I could. The thing is that how... Yeah, it would be a lot more complex to implement, I think. Still fun. But also, do I need to make my own kernel, or can I just do this with my own processes? Maybe I can just make a quick supervisor which has multiple tasks, and the supervisor itself has a scheduler, maybe. What is a cool page? Any of you guys know the YouTuber Cordam? He made a nice OS scheduling video. I don't know. Never seen that guy. Sporadic task, model deadline scheduling. It's nice they have little graphs. Okay, but I think I will read the man page on my own time and like extract the interesting bits maybe. instead of boring you by reading it all on stream. So anyway, I will go eat now. I hope you have a nice rest of your day, and I will see you later or another day. I'm not sure. Anyway,